In November 1917, in the Cambrai sector of the Western Front, German troops spotted a new kind of military hardware. Cutting through the morning fog toward their positions were tracked vehicles of an unusual design, distinguished by a low silhouette and a large caliber gun mounted right in the hull. The defenders were facing British heavy artillery mounted on a tracked chassis. This event marked the first time in history that a self-propelled artillery unit, designated the gun carrier Mark I, was used in combat. This development was a significant step in the evolution of armored warfare, but the reasons for its creation had emerged a year earlier, when fighting on the front had shifted into a phase of prolonged trench warfare crisis. By 1916, it had become obvious that the old methods of waging war had lost their effectiveness in these conditions. The front line, stretching from the sea to the borders of neutral nations, had stabilized, and any attempt at an infantry offensive resulted in heavy casualties due to dense machine gun fire and artillery shelling. To break through fortified defenses and overcome wire obstacles, the British command began using the first Mark I tanks. Although the new machines demonstrated the ability to cross trenches, their standard armament proved insufficient for destroying the enemy's permanent concrete fortifications. At the same time, the heavy field artillery needed for such tasks couldn't keep up with the offensive due to destroyed roads and difficult terrain. Traditional means of transport, like horses and wheeled tractors, couldn't cope with delivering guns across a landscape churned up by craters, often leaving attacking units without fire support. A need arose to create a transport vehicle capable of delivering powerful artillery systems directly to the front line. The project was initiated by Major John Gregg, an engineer at the Metropolitan Carriage Wagon and Finance Company, which was involved in tank production. He proposed the concept of using a tank chassis to transport artillery. The Mark I tank was chosen as the base. The hull was modernized and the turrets and sponsons were removed to equip a platform for a 60-pounder gun or a 6-inch howitzer, weapons capable of effectively destroying field fortifications. The design called for placing the artillery piece on a special platform at the front of the vehicle, while the carriage wheels were attached to the sides of the hull. The crew consisted of driver mechanics and the artillery team. The machine allowed for firing directly from the chassis, but the primary operational scenario was quickly delivering the gun to a position and then unloading it. To achieve this, the engineer developed a system with a pivoting cradle and winches that allowed the gun to be lowered, assembled on its wheeled carriage, and if necessary, rapidly loaded back up to change location. By the spring of 1917, the prototype was ready, and on March 3rd, official trials of the new hardware took place at the Oldbury Proving Ground. Representatives of the military command inspected the new armored models. The presented machine demonstrated the ability to move a total load of 31 tons, including the gun and a supply of 60 shells, while retaining its mobility. A 105 horsepower Daimler engine provided a speed of about 6 kilometers per hour, which was considered an acceptable figure for the conditions of positional warfare. The transporter could cross trenches more than 3 meters wide and move over ground that was difficult for wheeled transport. The Army placed an order for 50 vehicles with the Kitson Company in Leeds, after which serial production began. The facility worked around the clock to turn out the Mark I gun carrier. By the summer of 1917, 2 special companies had been formed within the British Army, each receiving 24 self-propelled units. The units were manned by skilled mechanics and seasoned artillerymen. Command saw this new machinery as a way to break through enemy lines by delivering heavy guns right to the critical sectors of the front. The vehicles were imposing in size, with a hull reaching almost 8 meters in length. This transporter was one of the largest combat vehicles of its time. Armor ranging from 6 to 12 millimeters protected the crew from shrapnel and bullets, though a direct shell hit could punch right through. For defense against enemy infantry, a Hotchkiss or Lewis machine gun was mounted on the hull. Its tracks allowed it to tackle obstacles that were impossible for the wheeled transport of the day. The machine could navigate shell craters, destroyed trenches, and deep mud. Crews went through intensive training as operating this machinery required specialized skills. The driver sat in a cramped space, looking out through narrow vision slits, while the commander coordinated movement and the mechanics monitored the engine and transmission. The artillerymen practiced unloading the gun and deploying it for battle in the shortest time possible. The effectiveness of the mission and the safety of the crews depended on their coordination. Command believed that successfully using the carrier in battle could change the very principles of artillery support. While the units were being formed, tactics for these new machines were being developed. The initial plan was to advance the carriers to the front line alongside the tanks, quickly unload the guns, and fire on fortifications from close range. It was a tactic that carried high risks for the crews. An alternative option was to use the machines to rapidly redeploy artillery between positions, providing much greater mobility for their firepower. In the fall of 1917, preparations began for the offensive at Cambrai. The plan called for breaking through the defense with a massive attack involving nearly 400 tanks. The carriers were given a significant role in the operation. They were to transport weaponry and support the combat mission. On November 20th, the offensive began and the self-propelled guns moved forward alongside the tank units and infantry. This large motorized force had to navigate terrain that had been heavily damaged by previous fighting. However, the reality on the front lines forced a change of plans. When the gun carrier vehicles arrived at the forward positions, it became clear that the rapid pace of the advance made deploying heavy artillery impractical. The tanks were clearing obstacles and suppressing enemy fire faster than the artillery crews could get their guns ready to shoot. Under these conditions, command decided to change tactics. They repurposed the machines, taking advantage of a load capacity that far exceeded that of any other armored vehicle available. While the modified Mark I and Mark IV supply tanks could carry 2 or 3 tons of cargo, the gun carriers were capable of hauling over 7 tons of supplies in a single run. Because of this, these self-propelled units were used primarily for logistics. They delivered ammunition for the infantry and armored vehicles, engineering equipment to fortify positions, as well as food and water. Transport operations ran between the rear and the front lines over difficult terrain and under fire. The vehicle's armor protected the cargo and the crew, while their technical specs allowed them to cross ground that was impassable for other transport. Given their effectiveness as all-terrain vehicles, their role was expanded. 2 units were even specially outfitted with cranes to handle recovery work. When tanks were immobilized by breakdowns or damage, these specialized transporters rolled out to recover them. This work took place in combat conditions, often under artillery fire and in close proximity to enemy positions. The crews salvaged valuable hardware, preventing the vehicles from being captured or destroyed. During the fighting around Cambrai, the machines proved their worth, performing duties far different from what was originally planned. According to historical records, there were no documented cases of the standard gun being fired directly from the vehicle's platform during the entire operation. Even though the design made it technically possible, the tactical situation simply never called for it. As transport and recovery vehicles, the gun carriers turned out to be in high demand. Frontline commanders urgently requested them to bring up ammunition and gear. The demand for these machines grew daily, pointing to a clear need for more of them at the front. During the winter of 1917-1918, weather conditions on the Western Front took a turn for the worse. The ground turned to mud, creating a serious obstacle for logistics. Standard trucks and horse-drawn transport got stuck even on the roads, while the gun carriers kept on working. Thanks to their wide tracks, which distributed the vehicle's weight, they could cross terrain that was off limits to other machines. British Army personnel praised the effectiveness of these units in delivering provisions and ammo. Evacuating the wounded also became a vital function. Medical services found that the vehicle's platform was suitable for stretchers, and the armor provided protection from enemy fire, allowing them to extract casualties directly from the front lines. Crews frequently operated in active combat zones. A machine originally designed to haul heavy artillery had effectively been repurposed as an armored ambulance. In the spring of 1918, during the massive German offensive utilizing stormtrooper tactics, British forces were forced to retreat. In this chaotic situation, the transporters were used to save artillery guns, equipment, and ammunition that couldn't be moved by any other means. Some units were running as many as 3 or 4 trips a day. Despite mechanical failures and wear on the running gear, maintenance crews managed to get the machines back up and running in short order. By summer, the front line had stabilized and preparations for the Allied counteroffensive began. An analysis of their operational history confirmed the gun carrier's status as an effective, universal, high-mobility transport vehicle. The military's need for these vehicles far exceeded production capabilities, which were limited to a batch of just 50 units. Command kept a tight leash on how the equipment was distributed among the units. On July 4th, the Battle of Hamel began, an operation designed for close coordination between different branches of service. Australian units were tasked with taking the village of Hamel and the surrounding heights, supported by tanks, aircraft, and carriers. Captain James Smith of the 1st Gun Carrier Company received orders to bring up engineering supplies to fortify the captured positions. 4 vehicles were allocated and loaded with bridging materials, barbed wire, tools, and explosives, a total weight of around 25 tons. This cargo was critical to the mission. The offensive launched at dawn with a massive artillery barrage on the German lines. Tanks pushed forward, crushing through the wire obstacles, with the Australian infantry following close behind. Captain Smith and his group of vehicles waited for the signal, monitoring the attack's progress. Once the report came in that the first line of trenches had been taken, the carriers began to move. The column navigated terrain scarred by shell craters, maneuvering around obstacles and destroyed fortifications. Despite return artillery fire and shrapnel pinging off their armor, the crews kept driving toward their objective. The Australian units pushed forward using flanking tactics. 30 minutes into the attack, the lead units had closed to within about 400 yards of the high ground behind the village. That was when Smith's vehicles reached the positions, having crossed the combat zone to deliver the engineering supplies right where they were needed. Sappers used the materials to fortify the captured ground and build crossings over anti-tank ditches. On the return trip, an evacuation was organized. The crews spotted wounded Australian soldiers waiting for help. The captain decided to use the transporters to get them out. About 70 men were loaded onto the platforms of the 4 vehicles, some on stretchers, the others huddled against the sides. The column headed back toward the rear under heavy fire. The drivers drove carefully, avoiding sharp maneuvers so as not to make the wounded men's condition any worse. Negotiating the rough terrain required maximum precision. The trip to the dressing station took about an hour. As they moved, German artillery hammered the retreating column. Shrapnel struck the hulls, but the vehicles kept going. When they arrived at the medical station, the staff took in the casualties. All 70 of the evacuated men survived. The armor protection and the actions of the crews ensured they made it out alive. This episode demonstrated the practical effectiveness and capabilities of these machines in the hands of trained personnel. After the events at Hamel, the reputation of these vehicles was significantly bolstered. Commanders at all levels began requesting this equipment for planned operations. Australian troops also insisted on including these carriers in their assault groups, noting their ability to conquer obstacles and ensure the timely delivery of supplies. The British High Command began planning a massive counteroffensive aimed at changing the strategic situation. Tracked carriers were assigned the role of the primary means of supply for the advancing units. August 1918 marked the beginning of a series of Allied operations across the entire front known as the 100 Days Offensive. The German army, facing a resource shortage after its spring campaign, began to withdraw. The pace of the troop advance increased, reaching several kilometers a day, which was a significant figure for the conditions of trench warfare. In this environment, it became clear that the existing supply system could not keep up with the dynamic combat actions. Rail lines remained in the rear, and wheeled transport lost traction on ruined roads, leaving forward units in acute need of ammunition and food. Gun carriers played a significant role during this offensive. The equipment was operated up to 20 hours a day with brief breaks for maintenance and refueling. Crews worked under extreme stress, ensuring the transport kept moving. Mechanics often repaired worn-out engines and transmissions directly in the field. Due to a critical shortage of spare parts, they had to strip components from damaged vehicles or use whatever was at hand. Some units logged hundreds of kilometers over these months, which was a high figure for that time. The enemy realized the value of these self-propelled units in the British supply chain, so artillery was given the task of prioritizing their destruction. When observers spotted the machine's characteristic silhouettes, they adjusted battery fire. In August and September, several carriers were damaged or destroyed, With no reserves available, every loss of equipment negatively impacted the supply of forward units. In late August, one machine took a direct hit from a shell during a run to the front line. The explosion destroyed the platform and there were fatal casualties among the crew. The surviving mechanics managed to evacuate the damaged vehicle from the shelling zone. In the rear, repairing the machine was deemed unfeasible and it was dismantled for parts to fix other units. In conditions of scarcity, resources were used as rationally as possible. In September, Allied troops reached the Hindenburg Line, a fortified defensive boundary with concrete structures, ditches, and barriers. The assault on these positions began on September 29th with massive support from tanks and artillery. The transporters delivered pontoons and bridge sections to cross trenches, explosives to blow up fortifications, and flamethrowers. The vehicles moved toward their targets under enemy fire, overcoming difficult terrain. By October, the operational situation had changed. The German army was retreating, and Allied forces were occupying territory. The gun carriers continued their work, supporting the pursuit of the withdrawing troops. The range of cargo expanded. They carried ammunition, fuel for tanks, food for the civilian population, and building materials to restore infrastructure. The functionality of the machines adapted to the transport tasks at hand. On November 11, 1918, at 11 a.m., the armistice took effect, bringing an end to the hostilities. The conflict, which had lasted 4.5 years, was finally over. The surviving equipment sat on the roads of France and Belgium, heavily worn down and suffering from numerous damages. Of the 50 machines produced, only about 40 survived the fighting. The rest had been lost or written off. British command faced the question of what to do with these vehicles. Shipping them back to England was deemed economically impractical. The engines were worn out, the transmissions required a major overhaul, and the armored hulls were damaged. With the military budget shrinking and demobilization underway, no funds were allocated to maintain the equipment. A few units were sent to proving grounds for testing, but the rest were scrapped and stripped for metal right there in France and Belgium. By 1920, practically every gun carrier produced had been scrapped or taken apart for spare parts. A small number were shipped to Great Britain for storage in arsenals, but even those were destroyed over the next decade. A lack of storage space and funding meant even these historic examples were sent to be melted down. As a result, not a single Mark I gun carrier has survived to the present day. All of them were disposed of as scrap metal in post-war Europe. Nevertheless, this machine left a significant mark on the history of weaponry. Technical experts and military theorists from various countries studied the British experience in detail, realizing that a fundamentally new class of combat vehicle had emerged. The concept of mounting a heavy gun on a tracked chassis proved to be innovative and defined the direction of artillery development for a long time. In the 1930s, the world's leading powers began designing their own self-propelled artillery systems. In Germany, the Sturmgeschütz assault guns were created. Soviet engineers developed the Su series. And in the U.S., a family of tank destroyers appeared based on the M4 Sherman. All these designs were based on the principles laid down by the gun carrier: a tracked chassis, a powerful gun, and armor protection for the crew. An idea born during World War I became widespread during World War II, when self-propelled guns became one of the most mass-produced types of armored vehicles for the warring sides. In the Soviet Union, this direction developed particularly actively. The Su-76, Su-85, and Su-100 vehicles were used both to fight enemy tanks and to provide fire support for advancing infantry. They combined firepower and mobility, allowing them to rapidly change positions. The principle proposed by Major Gregg in 1917 confirmed its effectiveness during large-scale combat operations on all fronts, making self-propelled artillery an integral part of the armed forces. In the post-war period, the development of self-propelled guns continued with increasing intensity. New models received automated targeting systems, high-performance diesel engines, and improved armor protection. Modern self-propelled howitzers are capable of firing from indirect positions at a distance of several dozen kilometers, automatically calculating trajectories and relocating immediately after a volley. Over 100 years, there has been a significant technological evolution from the gun carrier, with its speed of 6 kilometers per hour, to modern complex systems, yet the functional essence remains unchanged. the rapid and safe delivery of firepower to the necessary point. The Mark Y did not last long, having a combat service of about a year and a half, and it didn't gain widespread fame in popular culture like the tanks or aviation of that period. Nevertheless, it was this machine, created by British engineers, that opened a new chapter in the history of military hardware. It proved it was possible to combine mobility, protection, and firepower in a single combat unit. This marked the first step in an evolution of weaponry that continues to this day, as self-propelled systems remain a vital part of any modern army. The history of this technology clearly shows how engineering solutions from the early 20th century transformed into high-tech systems, radically changing the tactics of ground warfare and remaining relevant for armed forces around the world for an entire century.